In this video, we're going to go over a few problems concerning law of cosines. Okay, so example one here says let triangle ABC be a right triangle with a measure of angle C equal to 90. How does this affect the law of cosines? All right, so let me sketch out the right triangle first and label the sides and angles. All right, so we have a right triangle here. Angle C is the 90-degree angle here. How does this affect the law of cosines? So remember, when we're setting up the law of cosines, it looks like the Pythagorean theorem. We have little c and big C on opposite sides. So we'll have C squared, and then we'll have cosine of C all the way at the end here. And then we're going to fill in the blanks with the other two sides. So we have a squared plus b squared minus 2ab times cosine of c. But we know that c is going to be 90 degrees. So let's sub in 90 for the angle. So it's going to be c squared equals a squared plus b squared minus 2ab times cosine of 90. Well, what's cosine of 90 in the unit circle? Hopefully you guys are like, oh yeah, that's 0. So all of this just goes away. That just goes to 0. Okay. And then you're just left with now your final answer. If you look at this here, c squared equals a squared plus b squared. Aha. You've got the Pythagorean theorem, right? So that's what we have here. When the included angle is 90 degrees, the law of cosines results in the Pythagorean theorem. All right, so that's pretty cool. So that's why I was kind of saying, and Mr. Words kind of compared it to the Pythagorean theorem for big kids, because instead of it just being 90 degrees, we can have a little bit of variation now to our angles. Okay. So moving on to number 2. Find the three angles of the triangle in figure 11. All right, so this was actually from the do now. Like we couldn't set up a law of sines to solve for the angles. So here we now know that we have to set up the law of cosines. And I want to add an additional note here. So the note is that whenever you're using the law of cosines, when you're given all three sides, always, doesn't say, we don't use that in often in math, but always find the angle opposite the longest side first. And the reason why we do that is to avoid the ambiguous case later. So in this problem here, the angle that we would try to find first would be angle B. All right, so if we set it up using the law of cosines, we'll have little b on one side and then angle B on the other. So the equation should look something like this. So we'll have side B and angle B on opposite sides of the equation, and then we fill in the rest of the law of cosines with the appropriate side lengths. So we'll have 8 squared plus 14 squared minus 2 times 8 times 14 times cos of B. Okay, and what we want to do to try to solve for the angle is we need to isolate the trig function. So I'm going to do a few algebraic operations all in one shot. So we would have to move this 8 squared, move this 14 squared over by subtracting both of these terms over to the left side. And then what we'll have left, this is essentially the negative 2 times 8 times 14 is a coefficient. So we would have to just divide this over to the other side. So when you isolate the trig function, it should look something like this. So now we have cosine of B isolated to one side, and then to solve for the angle, we would just have to take the cos inverse of both sides. So we'll have cos inverse of that fraction, 19 squared minus 8 squared minus 14 squared, all over -2 times 8 times 14. We'll put that all into the calculator, and that's going to be our angle measure for angle B. Okay. And then to do to 2 decimal places, B is going to be about 116.80 degrees. 116.80 there. Okay. Now, once we set this up and we find this angle measure, you're looking at it and you're like, wait, now I can set up, I don't have to use a law of cosines, right? I have a complete ratio, and that's what I would do, okay? Once you have the one ratio complete, you can just use a law of sines to solve the others, okay? So I just had to move some stuff over so I would have a little bit of room to solve for this here. So we set up the law of sines from here to set the to solve for the other angle. So we'll have sine of 116.8 over 19 equals sine of A over 8. So when we when we multiply and solve here, we'll have 8 times sine of 116.8 over 19 equals sine of A. And then we would just take the sine inverse of this value here, type that all into your calculator. 8 times sine 116.8 over 19. So angle A is going to be about 22.08. Okay. And then angle C, right? We could just add these two together. So this is angle A. And then we could just say, well, angle C is just 180 minus angle B plus angle A added together. So angle C should be about 41.12. And the order doesn't matter. Like if you did angle C instead for the law of sines, your answer may be off by like 100th, but big picture, it's not that big a deal. Okay. All right, so now let's go to one more example. Find the remaining angles and side of the triangle in figure 12. All right, so looking at example 3 here, all right, it looks like, oh, we have an angle here. And then if we were to try to set up the law of sines, sine of 115 over A, and then if we were to do B, this angle B and 15, we would have two variables. So that's how you know, like, okay, dang it, I can't quite do law of sines. So this is definitely another law of cosines case. And we have angle A and little a opposite from one another. So that's what we're going to solve first. Okay. So we'll have, it should look like this. A squared equals the two sides here in the included angle. So we'll have 15 squared plus 10 squared minus 2 times 15 times 10 times cosine of the included angle. All right. And then to solve for the side A, we would just type all this into the calculator as a square root. 15 squared plus 10 squared minus 2 times 15 times 10 times cos of 115. Okay. And then rounded to 2 decimal places, this is going to be about let's see, 21.26. Okay. So now now that we have one set of sides and angles, we can complete one trig ratio or one law of sines ratio. So we'll say sine of 115 over 21.26 equals sine of b over 15. And again, it doesn't matter if you did b or c first. I'm just going to do b alphabetical order. So I'm going to do this in one shot. We would multiply by 15 and then eventually take the sine inverse. So it's sine inverse of 15 times sine of 115 over 21.26. So this is going to be about 39.75 degrees. So angle B. And then you can find angle C, same way, right? Angle C is equal to 180 minus angle B and angle A added together. Why, if you don't have to set up another law of sines or a law of cosines, let's just skip straight to kind of the easiest way to do it, and it'll be 25.25 degrees. All right, those are three examples using the law of cosines.